Sometimes you need to join a table to itself. We use a self-join to join a table to itself in a SQL statement. To find the name of each employee's manager, you would need to join the employees table to itself. For example, to find the name of Ernst's manager, you need to first find Ernst in the employees table by looking at the last name column. Then find the manager number for Ernst by looking at the manager ID column. Ernst's manager number is 103. We then find the name of the manager with the employee ID 103 by looking at the last name column. Hunold's employee number is 103, so Hunold is Ernst's manager. In this process, you look at the table twice. The first time you look in the table to find Ernst in the last name column and the manager ID value of 103. The second time, you look in the employee ID column to find 103 and the last name column to find Hunold. The ON clause can be used to join columns that have different names within the same table or in a different table. The example shown is a self-join of the employees table based on the employee ID and manager ID columns. In the from clause, we specify the employees table twice. The first reference to the employees table, we give the table name and alias worker. We then join to the employees table, giving it an alias manager. The columns that we join on in the worker table, we use the manager ID column. And in the manager table, we use the employee ID column for the self-join. The select clause lists the column depending on whether it should come from the first reference of the table, the worker alias, or the second reference, the manager alias. Let's go to our SQL Developer session, where we will amend this SQL statement to demonstrate information that can be retrieved using this self-join statement. Our first SQL statement in the SQL Worksheet window is the SQL statement from our presentation slide. We're going to select the worker last name and the manager last name from the employees table, defined with the worker alias, joined to the employees table with the manager alias. Our join is on the worker.managerID, where it is equal to the manager.employeeID. Let's execute this statement and review its output. In the query result, the last name for each employee is returned, including the last name for the manager per employee. In our next SQL statement, we have amended the SQL statement as we would like to see a list of the distinct manager IDs and their last names. Our SQL statement was amended. We've included the distinct keyword. We are now selecting the employee ID from the manager table and the manager last name. The from and on clause remain the same. We've included an order by clause. We're going to sort our rows by the manager's last name. Let's execute this statement. In our query result, we can see that we've returned 18 rows. We have the manager employee ID and the manager's last name. This is a distinct list of all the managers. For our last SQL statement, we would like to restrict the results returned by the SQL statement to return only a list of employees for manager ID 103. We would like to see the last name for the employees and the manager. In our SQL statement, we select the worker last name, the manager's last name. We're selecting from the employees table, giving it an alias worker. We are joining on the employees table, and we are giving this table the alias manager. We are joining where the worker manager ID is equal to the manager employee ID. We've included a where clause as we would like to return the rows where the manager employee ID is equal to 103. We've then ordered our data to be sorted by the last name of the employees. Let's execute this statement and review the output. In the query result, we can see we have 4 employees that report to manager 103, and we've returned the employee's last name and the manager's last name. You are now ready to join a table to itself by making use of a self-join in a SQL statement.